What we have here is a data set of car prices in thousands of dollars. So this is $14,600 and the odometer reading in thousands of miles. So that's 37,000 miles. We want to find a relationship between price and the odometer reading. It makes sense to say that the number of miles a car has is going to influence the price. So more miles means less price. It does not make sense to say that given a price, that would have that many miles. So because it's $15,000, we don't think that that is really going to mean it has a certain number of miles in the odometer. So the relationship is going from the odometer to price. All right. What we want to do now is regression between these. So price is what we're trying to predict. That's our y variable, or a dependent variable. And odometer is our independent variable, or our x variable. We will do this with XLSTAT. So I'll click on that, XLSTAT right here. Then modeling data and linear regression. That's going to open up a dialog box. Here we go. Just jumped way over to the side. It's because I've kind of zoomed out. Oh dear, it's really super small. I don't know why XLSTAT's doing this. Here we go. So our dependent variable, so we're trying to predict, is in column A. Just click A. Our independent variable under quantitative, independent and explanatory mean the same thing. That's column B. That's all we need to do. We'll hit OK. It will think for a moment. It asks us to verify this. We'll say continue. And it's finished. Just kind of zoom in a little bit. So it starts by giving us some information about number of observations, maximum and minimum values, standard deviations. And then we have three big blocks here. That we care about. This first one is called goodness of fit statistics. And this is telling us how well our regression explains the variance in the model. Specifically, we're looking at the r-squared value. So that is the proportion of the variance explained by the model, the proportion of the variance in price that's explained by the model. The best value for r-squared would be 1, the worst is 0. So this is pretty good. It explains 64.8% of the variability in price. You can see regression variable is price here. The next block we have is an ANOVA. And this is telling us overall if this model is worth anything. We look here at our F statistic, and this is saying whether or not all of our coefficients are actually equal to 0. And because this value is very large, we would conclude that it's not the case. We would reject the null hypothesis that they're equal to 0 and conclude that this model could be useful. Just going to add some decimal points here. Now we're down to our model parameters. First is our intercept. That's just the initial value we'll start with. And this one here is called our beta naught, so B0. This value here is our coefficient for odometer. Right? It says value, but that's the same as coefficient for odometer. What this is saying is that for a 1 unit increase in odometer is associated with this number decrease in price. Here is our model written out. Okay, So as odometer goes up, price goes down by this number. We need to be careful because the price and the odometer readings are in thousands. So a 1 unit increase in odometer is actually 1,000 additional miles, and price is also measured in thousands. So just how we interpret it, have to be careful that we're using the right units here. All right, so we've got our value for odometer. We have a t-value that's showing us the null hypothesis is that this value is actually 0. And the t-value is telling us if that's the case or not. Because this t-value is very large, the probability that this is 0 is very small. Okay? To get this value, this 13 is equal to the value of the coefficient divided by the standard error. Okay, that gives you the t-value. Finally, we have our upper and lower bound confidence interval. So the value for odometer could be as low as negative 0.07 or as high as negative 0.05. That's just a range, a confidence interval. Okay. Now we have this equation. And so we have a bunch of information it presents here and some graphs at the end. To use this, we can say, let's come up with some values for the odometer, values between 19 and 49. So let's try 25, 30, should be 30, and 35. So this is equal to our intercept plus the odometer times it's like blocked off this, oh gracious, times this. All right, so if it has 25,000 miles, the expected price is $15,577. Okay. Same thing would be here. We can take our intercept, and we add 30 times our coefficient. Right, you can see the price went down. And finally, this one is the intercept plus right, so we can see this downward linear trend. That's how we would predict values using XLSTAT.